The last section of chapter 8 is talking about parametric equation and graph. You can thinking about when we try to graph any function on xy plane, and the graph itself, it just happened at once. However, in real time or in real life, when we're talking about any applications, there are patterns, there are timelines between from one point to the other one, how the graph is moving from point A to point B. So this one, parametric equation, is going to implementing another variable, t. You can interpret it as time. It's going to talking about, yes, we are going to have, for example, a parabola graph, but the parabola graph have a direction from one point to the other point. So here we're going to introducing a plane curve. That is going to be the graph. The plane curve is going to be a set of point x, y, so it's very similar to the definition of any graph, such that x is defined as a function of t, y is defined as a function of t, and f and g are both defined on the interval I, so you can thinking about t is living inside the interval I. Then we're going to call the equation x equal to f of t, and then y equal to g of t as the parametric equation with the parametric t. So we can looking at one example. So here I tell you that I have the parametric equation x is defined as t squared minus 1, and y is defined as t minus 2. And then I tell you t is living between -3 to 3 including. And when we want to graph the ordered pair x, y. So to do it, we're going to build the tables. We're going to have three parts, the t, the x, and the y. So I have t, x, and the y. So t is going to be living inside -3 to 3. I'm just going to write down all the numbers. So -3, -2, -1, 0, 1, 2, and 3. X is going to be defined as t squared minus 1. So when t equal to -3, x is going to be 9 minus 1. So it's going to be 8. When t equal to -2, x is going to be 4 minus 1, so 3. T equals to -1, x is going to be 1 minus 1, so 0. And then when t equals to 0, x is going to be 0 minus 1, so -1. And then repeating 0, 3, 8. Y is defined as t minus 2. So when t equal to -3, y is going to be -5. -2 minus -3 minus 2. When t equal to -2, y is going to be -4. When t equal to -1, y is going to be -3. When t equal to 0, y is going to be -2. When t equal to 1, y is going to be 1 minus 2. So -1. When t equal to 2, y is going to be 2 minus 2, 0. And when t equal to 3, y is going to be 3 minus 2, 1. So we have the ordered pair, x, y, as 8, -5, 3, -4, 0, -3, -1, -2, 0, -1, 3, 0, and 8, 1. So now we're going to graph them. So the first point we wanted is going to be 8, -5. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, -5. The second point is going to be 3, -4. 3, -4. 0, -3. -1, -2, and then 0, -1, 3, 0, and then 1, 8. Okay, now we're going to connect them. I'm using different color. Okay, so since the t is living inside the interval -3 to -3 to 3, so the graph we have is going to be stopped at the 8, -5 and 8, 1. And since t is moving from -3 to 3, that means the point is moving from 8, -5 to 8, 1. So besides the dot connecting the point, connecting the dot, and we also need to label the direction. To talking about, okay, the graph is, or the point is moving from one direction to the other direction.